"12 a.m. Young molten Earth collides with another planet called Theia. The moon is formed. From 12 to 4:30 a.m., the planet and atmosphere are morphing. The continents merge to form supercontinents. They break up again. This happens every 400 million years. That's every 2 hours on the clock. At 5:30 a.m., we see the first single-celled organisms starting their life in the ocean. It's 8 a.m. when the first viruses emerge. By 11 a.m., photosynthesizing bacteria have managed to take in enough sun to fill the atmosphere with oxygen. It takes 1 billion years. That's 6 hours on the clock. At 11:35, we have the first snowball Earth. Even the oceans turn to ice. Don't worry, everything will melt by noon. At 1 p.m., we have special cells with internal organs coming to life. 3 hours later, they'll start to divide into 3 groups that will eventually become fungi, like mushrooms. Let's fast forward while these cells go from simple to complex life forms. At 7:20 p.m., something familiar appears: sponges. It's 7:55, and the Earth freezes over again. It melts in 2 minutes. 8 p.m., and look in the ocean. We have the first comb jellies appearing. At around 8:30, the Earth's ozone layer appears. In just 2 minutes, the ocean is filling with plants. By 8:45, life is flourishing in the sea. We now have jellyfish swimming around corals. Starfish are on their way. At 8:52, we can see trails on the ocean floor. Creatures have begun to crawl. It's 9:10 p.m. The sea creatures decide to explore the land. 30 seconds later, different animals and plants emerge. They spread all over the planet in an instant. 9:41. It's time for the first insects. They feed on newly formed plants and trees on land. By 9:45, we have the first 4-legged animals appearing in shallow waters. At 10:10 p.m., those 4-legged creatures are splitting into groups that will later become mammals, reptiles, birds, and dinosaurs. By 10:30, everything vanishes. Mass extinction takes place. Either a huge asteroid or an enormous volcanic eruption causes it. Only 5% of the species survive. 10:34, and the dinosaurs are finally making an appearance. The first one was the Nyasasaurus, but experts aren't sure if it was the real deal or a relative turning into a dino. 10:45 marks another mass extinction. The early dinosaurs survive it and take the opportunity to spread all around the world. In 5 minutes, the Tyrannosaurus will appear. By 11 p.m., we have the first birds appearing in Europe. It's 11:15, and mammals are splitting into their groups. They'll branch out, forming whales, elephants, armadillos, and primates. By 11:17, dinosaurs are reaching their full size. The biggest one ever is the Argentinosaurus. It's the length of 10 school buses and tall enough to peek into a 7th-floor window. It's 11:26 when a giant asteroid smashes into the Earth. Dust flies everywhere. A few seconds later, everything clears up, but the dinosaurs have already disappeared. With the dinosaurs gone, the few mammals left can take over the planet. At 11:30, the primates separate into 2 groups, and one of those will become apes, gorillas, and, sometime later, humans. It's 11:58 p.m. The chimpanzees and bonobos appear. 15 seconds later, the hominin species begins to walk on 2 legs. It's 11:59 and 23 seconds, the time when humans appear in Africa. A second later, they've migrated all over the world. They don't have a language, and they can't use or create tools. That happens at 11:59 and 58 seconds. 2 seconds before the day ends, 100,000 years ago, our complex human species appears.
So we don't have all the details about how the universe, our solar system, and its planets came to be. But one thing's for sure, Earth didn't just pop out of thin air. Scientists have recently made an intriguing discovery that suggests our planet may have formed way faster than we previously thought. You see, up until now, experts believed it took over 100 million years for Earth to take shape. The common belief was that lucky collisions with water-rich asteroids brought water to our planet. A recent study, however, proposes a whole new perspective. According to these researchers, there's evidence that Earth formed through the rapid accumulation of tiny pebbles, each roughly the size of your fingernail. In this scenario, our awesome planet emerged in only a few million years. And here's the mind-blowing part. They suggest that water being here isn't just some happy accident, but a natural result of the formation process. Now, this discovery has implications that go beyond Earth itself. If our planet formed quickly and water was an integral part of the process, it means the chances of finding habitable planets in other solar systems are way higher than we ever imagined. If we stumble upon other planetary systems with planets orbiting sun-like stars at the right distance, there's a good chance we'll find water there too. That's some nice intergalactic real estate that we might just be able to relocate to, should we ever get in trouble here on Earth. The old-school view was that planets slowly took shape through countless collisions over millions of years. According to that theory, water on Earth would have been a random stroke of luck, maybe caused by comets packed with water crashing into the planet during its later stages of formation. The new study introduces an alternative theory too. Picture this: a young sun surrounded by a disk where the planets are popping up. This disk is filled with tiny dust particles. Now, here's where it gets exciting. Once a planet reaches a certain size, it acts like a cosmic vacuum cleaner, swiftly hoovering up all the dust in its path. In just a few million years, this tiny planet grows into the size of Earth. This not only shapes our incredible planet, but guarantees water's existence too. As the planet gobbles up the dust, it also snags icy particles floating around in the disk. So, if we use Earth as an example, it suggests that whenever a similar planet forms, it's bound to have water naturally. There's no way for us to travel back in time and see for ourselves, so there are more theories about how planets are born. Let's dive into a different scenario called the core accretion theory. Picture a big cloud of dust twirling around in space. That's where the action begins. Over time, this cloud starts pulling in an astounding 99.8% of all the matter, eventually creating our sun right at the center of our solar system. Soon enough, solar winds join the party, bringing in lighter atoms like hydrogen and helium that are closer to the sun. But those heavier elements? The sun can't pull them in because, well, they're too heavy. So what do? They gather together and stick to each other, forming their own little planets. That's how Earth, Mars, Venus, and the gang got together to create round spheres. The heavyweights, like zinc and iron, sank to the middle, forming the core, while the lighter elements meshed on top, creating the crust. But wait, we can't forget about Jupiter. Its gravitational force and the Sun's were locked in an epic tug-of-war, perfectly balancing each other out. That's why we have that fascinating asteroid belt hanging out between Mars and Jupiter. Those poor asteroids never got the chance to become fully fledged planets on their own. This explains why the planets in our solar system are arranged the way they are. The inner ones, known as the terrestrial planets, like Mercury, Venus, Earth, and Mars, are closest to the Sun. They're made of denser stuff like iron, silicon, and aluminum. On the flip side, the gaseous giants, like Jupiter, Saturn, Uranus, and Neptune, are chilling on the outer edges of the solar system. These big celestial bodies are composed of lighter materials, such as hydrogen, helium, and methane. Now, let's take a trip to the outermost layer of our solar system, where the Kuiper Belt and the Oort cloud reside. These distant areas are home to ice bodies, space debris, and comets. While there may be plenty of them, they're relatively small and don't contribute much to the total volume of our solar system. The quest to understand planet formation doesn't end here. There's another mind-boggling mystery that's causing a stir among scientists: the existence of a celestial body dubbed the planet that shouldn't exist. Let's rewind a bit. Astronomers have been on a roll with exoplanet discoveries, and we've already spotted over 4,000 of them. Most of these exoplanets resemble the gas giants in our own solar system, like Jupiter and Saturn. Do you know why? It's because those massive exoplanets close to their stars are the easiest to detect. But here's the twist. A new study suggests that there's a whole bunch of Jupiter-like exoplanets just waiting to be found, and they're probably hanging out nearby. This impossible planet goes by the impossible name JG3512b, and it's remarkably similar to Jupiter, only orbiting a tiny red dwarf star. This discovery shook things up because it defied the most popular theory of planet formation. According to the prevailing ideas, it should have been impossible for such a giant planet to form around such a small star. So, what's the deal with this impossible exoplanet? Well, it turns out that core accretion, the theory we discussed earlier, can't explain its existence. According to this theory, the mass of the debris disk surrounding a young star should be directly proportional to the star's mass. But here we have a star much smaller than our Sun hosting a planet that should be way too massive for it. Something doesn't add up. Either the original debris disk was insanely enormous compared to the star, or core accretion didn't play out as expected in this particular planetary system. We've established that when talking about the Earth's formation, there's still much we don't know. But hey, we've come a long way. Back in the 18th century, a philosopher named Immanuel Kant had his own intriguing theory about planets popping up in the universe. He based his ideas on Newton's law of gravity, but added his own little twist. Kant believed that the universe started with an original substance made up of super cold, solid particles just chilling out. Then, thanks to gravity, these particles began colliding and heating up. And you know what happens when things collide, right? They get hot. According to Kant, this cosmic twirling and heating up caused some serious forces to come into play. It's like when you spin around so fast that you feel like you're about to take off. These forces led to the formation of rings of matter, like cosmic hula hoops. And as these rings cooled down, they transformed into planets and satellites. Now, not everyone was convinced by Kant's wild idea of planet formation. Critics raised their eyebrows and started questioning the whole theory. They pointed out that Kant failed to address the origin of this primordial matter. Where did it come from in the first place? Moreover, he overlooked the source of energy that propelled these particles from a state of cold stillness to a frenzied cosmic dance-off. As creative as his theory was, it soon faced dismissal in the scientific community. In short, they said, this can't happen. Nevertheless, Kant's theory was still a step forward compared to older beliefs about Earth's origin. Take the ancient Egyptians, for example. They believed that primordial spirits, often depicted with frog heads in their native artwork, were responsible for our planet's existence. Why frogs, you ask? Well, they associated the first substance in the universe with water, and frogs just love humid environments. So, out of that initial water, a primordial hill emerged, followed by the elements of air and moisture. Ribbit. So, scientists have this idea that some exoplanets, which are worlds outside our solar system, might be water worlds. They orbit their distant stars, covered by global oceans. Even better, some experts claim that our Earth was once the same, a vast expanse of the ocean, and just a bit, if any, visible dry land. At the moment, water makes up 71% of Earth's surface. Our planet experiences continuous movement of water. First, water evaporates, rising from the ocean surface to the atmosphere. Then rains fill lakes, rivers, and underwater reservoirs. Eventually, all this water ends up in the ocean again. Water also plays an extremely important role in the processes happening below the ground. For instance, water content in magma determines how explosive a volcano can be. Anyway, one of the most burning questions about Earth's water is, where did it all come from? It's very unlikely that our planet was simply born this way. The thing is, water has a way lower condensation temperature than some other substances, like silicates or iron. These materials compose the terrestrial planets in the solar system. In the early history of our planetary system, The region where Earth formed was too hot for the oceans to condense at the same time as our planet appeared. So there's this idea that water appeared on Earth when melted meteorites hit the surface of our planets. Well, scientists disagree. Researchers analyzed some melted meteorites that had been hanging around in space since the formation of the solar system about 4.5 billion years ago. They discovered that those space rocks had extremely low water content. Even more surprising, they were among the driest extraterrestrial materials ever found and examined. In other words, once they melted, there was essentially no water left. These results were very important, since they helped scientists rule out melted meteorites as the primary source of water on Earth. Plus, we can say that this revelation was kind of eye-opening. Imagine the unlikely conditions that aligned to make our planet habitable. Getting water and developing surface oceans on a planet so small and so close to the Sun is a great challenge. If Earth had formed just a tiny bit closer to the Sun, our planet would have been much hotter, and all the water would have most likely evaporated. If it had been farther away from our star, Earth would have turned out to be much colder, and the water would have probably frozen into ice. The team of scientists managed to analyze 7 melted meteorites that had crashed into Earth. Those must have splintered from at least 5 space objects known as planetesimals that later collided to form the planets in our solar system. These planetesimals took part in something known as melting. They got heated up as a result of the decay of radioactive elements in the early solar system. This caused them to separate into layers with a core, mantle, and crust. Plus, the heating and melting of planetesimals apparently led to near total water loss, regardless of how much water they started with. As for meteorites, some of the samples arrived from the inner solar system where our planet is located. The conditions here are relatively warm and dry, so it's no wonder the meteorite samples didn't contain much water. But a few samples were from the colder outer reaches of the solar system. That's from where the water is believed to have come to our planet. But if this water hadn't been delivered by meteorites, what kinds of objects could have carried it all the way across our planetary system? There's one more theory, though, that hydrogen inside our planet played an important role in the formation of the oceans. At the same time, these two ideas are not mutually exclusive. Water could have been delivered to Earth by impacts from some space bodies, like asteroids from the outer edges of the asteroid belt, spanning between the orbits of Mars and Jupiter. And some amount could also appear inside our planet. There's also a theory that claims that Earth gradually grew by accumulating icy planetesimals about 4.5 billion years ago. At that time, it was still only 60 to 90% of its current size. According to this theory, Earth managed to retain a certain amount of water in some form throughout the process of accumulating its mass, and as a result of large impact events. It sounds quite plausible. The examination of the chemical composition of lunar samples brought to Earth by the Apollo 15 and 17 missions indicated that water had already been present on our planet before the Moon was formed. So far, all these ideas remain just theories. At the moment, we don't know for sure how water appeared on Earth. What we do know is that there are many other space bodies that have water in this or that state on their surface, or under it. Let's start with our dear Moon. On Earth's natural satellite, water can be found all over the surface, but it's probably not the water you imagine. You won't find pools of liquid water there. On the Moon, it's mostly ice. Some places have more water than others. For example, the poles of the Moon are regions that never get any sunlight. That's why they're extremely cold, and there's a lot of ice there. Plus, the ice in these areas is often mixed with the lunar soil and hidden deep below the surface. Then there's Jupiter's moon Europa. Astronomers consider this world to be one of the most promising places in the solar system to search for new life forms, all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, the temperature, pressure, and chemistry are far different on Europa. Scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water reservoirs on Europa are, or how long they need to refreeze. Enceladus is the sixth largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. Wait, we should try that. Never mind. When the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then they saw plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a massive ocean between the moon's rocky core and its icy shell. If you've been imagining Mars as an extremely dry place, you need to listen to this. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that can only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water in Mars's polar regions, but the only place where this water is visible is at the North Polar Ice Cap. Sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Since we know for sure there is liquid water on Mars, could we possibly use this water during the human-operated mission to the red planet? If we manage to do it, spaceships coming from Earth wouldn't have to bring their own water. It would make the cargo way lighter, which, in turn, would decrease the cost of the mission. We would just need to take enough water to get to the red planet and bring along the equipment needed for filtering Martian water to make it drinkable. Well, it sounds simple enough.
An hour after people disappear, most urban areas will be left empty and quiet. Perhaps the sound of wind, falling leaves, or other natural sounds previously drowned out by city noise and traffic will be heard. The subways of many cities are protected from groundwater by a system of pumps. If there are no people to monitor such systems, most subways will flood within 36 hours. Due to malfunctions, sewage treatment plants will stop working, leading to pollution of rivers and lakes with wastewater. The water pipes in Detroit will become unusable, leading to the flooding of the city. Food in refrigerators will spoil. Raccoons and wolves will inhabit abandoned human homes. Major airports will be covered in rust and overgrown with ivy. Cruise ships in Alaska will sink under the weight of ice that accumulates on them. Lions from the San Diego Zoo will gradually escape, emboldened by the power outage of the electric fence around their enclosures. More and more black cats will appear on the streets of Rome and the Vatican. Rats and mice will consume all edible reserves and leave the cities. Plants will begin to grow in cracks in streets, highways, sidewalks, and buildings. More and more animals will notice the absence of people and flock to the cities. International Space Station will gradually decrease. Since no one will correct its orbit, the station will eventually fall to Earth and burn up. Along with it, digitized samples of human DNA will perish. A large part of the city's territory will be covered with a vegetation of lianas, grasses, and tree seedlings. The Red Square in Moscow will have a layer of soil and thick grasses growing, making the square completely green. Despite high levels of radiation, animal populations are increasing in abandoned areas. Plants have grown in many houses and buildings. Seawater will flood cities that were once drained by artificial drainage systems, such as London and Amsterdam. Satellites will begin to fall to Earth. Since no one maintained their speed of movement, they slowly approached Earth and eventually fell to the planet's surface. Wolves now roam freely around the Brandenburg Gate in Berlin, and wild boars will be seen in Paris. Human speech will be preserved in rare words that parrots have memorized during their years of living with humans. Snakes will not only reproduce at incredible rates, but also grow much larger in size. Their main prey will be rodents that have multiplied in the first years after humans disappeared. Many human-made structures will collapse within 100 years, primarily those with a large number of steel elements. Fruit Christmas cakes, thanks to their alcohol coating, will not only retain their appearance but also freshness. Most buildings will be overtaken by plants and animals, and the city will resemble more of a wild nature landscape. The period of nuclear fuel decay will come to an end, and as a result, dead zones around the ruins of nuclear power plants will once again become habitable. The last parrots that spoke human language may go extinct since they memorized human speech, but it is simply not necessary for their survival in the wild. All modern carriers of information that preserve human culture, laser discs, photographic film, paper, and the like, will turn to dust. Rebar inside concrete buildings, which are more durable than steel ones, will expand 3 times due to rust, causing the destruction of concrete structures. Most modern cities will be covered by a green blanket, and collapsed skyscrapers and buildings will become new hills. Manhattan will return to its former state before human settlement, with numerous streams and lakes. There will be almost no evidence of the existence of human civilization. Only powerful stone buildings that rely solely on the force of gravity will survive, such as Notre Dame de Paris. Of the products that existed during human civilization, only honey, especially in clay pots, and oil in wooden barrels, will be well preserved. Only a few stone structures will survive, including the pyramids in Giza and the Sphinx, almost entirely buried in the sands of the desert, and fragments of the Great Wall of China. By this time, a new ice age will begin on Earth. It is expected that the KEO satellite will enter the atmosphere by this time. Various pieces of space debris will collide with it during its descent, but this will not destroy the satellite. Eventually, it will fall into the waters of the world ocean. Remnants of spacecraft and satellite debris will float through space as the only reminder of human civilization.